Today, we're going to cover skills on solving multi-step inequalities, developing what we have already learned about inequalities with doing more steps within a single problem. So, information, solving inequalities with multiple steps is the same as equations, with the exception of the two rules regarding the inequality symbol or signs, symbols or signs. Okay. And just as a reminder, what those rules were. Rule number one is that you keep the inequality sign the same, you do not change it, except for when you multiply or divide with a negative number. Now, remember, the reason why the sign changes when we have multiplying or dividing by a negative number is because of the negative sign rules. When you multiply by a negative to a positive, your answer is negative. When you have a negative times negative, you get a positive answer. And so when you do that, it will change what happens with your negative numbers. And that is why we have to change our signs. So let's look at our first problem. So the instructions specifically for the note or for the problems are for the following. Solve the given inequality and graph the solution. Show work. So number one, we have 2n plus 4 all divided by 2 is greater than 11. So we want to solve for n. So keeping in mind our rules that we've learned about with equations, in order to isolate this variable, we have to remove the fraction bar here. So we have to get rid of the denominator. So we are going to multiply both sides by 2. That means this 2 divided by 2 will become 1, which leaves me with just the numerator. And over here, we have 11 times 2. Now they're both positive, so no signs need to be changed. So just 22. Then we proceed and keep going. From here, we're going to subtract 4 to both sides. And again, the rules only affect the inequality signs when we're multiplying or dividing by negative. This is just subtraction, so my sign is going to stay the same. So 22 minus 4 is 18. Getting closer to isolating. Then we're going to divide by 2 on both sides. And n is greater than 9. So once you have your answer, you also need to do your inequality sign. And those the inequality number line. So remember, we need to have a minimum of 5 integers. And the rule of thumb I've always said is put the number you're looking for or working with in the middle. And then 2 more and 2 less on either side. Then we have to consider if it's an open or closed circle, meaning is 9 included or is 9 not included? And 9 isn't included, and that's because it's just greater than, not greater than or equal. So it's an open circle. And we want values greater than 9. So that means all values to the right. And that would be my answers for number 1. So we have the work, we have our statement here, and then we have our number line. Let's go ahead and try number 2. 4/3 times the quantity, -9y plus 12 quantity plus 4y is greater than or equal to 48. Okay, 4/3 times the quantity, which means parentheses, -9y plus 12 parentheses plus 4y is greater than or equal to 48. Okay, so the first thing we're going to do is distribute our 4/3. We're going to distribute 4/3 just to what's inside the parentheses. To make your life, to think about it in a different way, you can think of it as each of these being divided by 1, and that can help you. So if we think about this, okay, the 3 and the -9 can simplify if you do cross simplification, not multiplication, cross simplification. So this would simplify to -3. -9 divided by 3 is -3. And multiply, we would get -12y. Again, I kind of said it out loud, but to show the work, 3 divided by 3 is 1. -9 divided by 3 is -3. 4 times -3 is -12. Okay. And then we're going to add, okay, similar thing. 4/3 times 12 over 1. 3 divided by 3 is 1. 12 divided by 3 is 4. 4 times 4 is 16. Okay, and then this 4y was not multiplied to because it wasn't within the parentheses. And then we have this. Okay, and as you can see, we have 2 different variables. Sorry, the same variable, but 2 different terms. So therefore, we want to combine like terms to make that one term. So -12y plus 4y give me -8y. And we just keep going with the process. Okay, go ahead and try that, and we'll be back and check. All right, let's see how we did. So first we should subtract 16 from both sides. So I get -8y is greater than or equal to 32. Then I'm going to divide by -8. And this is going to cause my inequality sign to switch. And because we divided by a negative number, that means my sign has to switch, and we get y is less than or equal to -4. Okay, and again, because of those negatives, and due to our negative rules of a negative times a negative or a negative times a positive or dividing, that is the reason why we have to change that inequality sign. And we'd finish that up with a number line. Now remember, when you're dealing with negatives, you have to consider that it's going to seem a little backwards to the eye if you think about it. But the numbers to the right have to be bigger, so they have to be closer to 0 if we're in the negatives. Okay. And then we consider if it's an open or closed circle. So is -4 included? It is, because it's or equal to. So that means we have a solid circle. And then we actually want values that are less than or equal to -4. That means all values to the left. Okay, hopefully that went well. And let's try our next one for number 3. All right, number 3. Negative a divided by 7 plus 22 is greater than 11. Negative a divided by 7 plus 22 is greater than 11. Okay, now on the last problem, or sorry, on the first problem, I should say, we said that we have to get rid of any fraction bars. Now that only applies when it's the whole thing. Currently, we have this plus 22 on the side. So we want to first remove the 22, and then we will deal with the denominator in this situation. Okay, so unless the fraction bar goes all the way across, that would be our first step. But in cases where you have a fraction plus or minus another number, you want to get rid of that number first using our inverse operations, and then deal with removing the denominator using our inverse operations. Okay, so go ahead and try number 3 and report back when you've completed it. So with the hint I gave beforehand, let's see what we did. So we should subtract 22 from both sides. And we get negative a divided by 7 is greater than negative 11. Then we want to remove this 7. Now, we also have that negative in here. So rather than doing 2 more steps, I'm going to do this in 1 step. And I'm going to multiply by negative 7. Because we also need to get rid of that negative. So we might as well do it at the same time versus multiplying by 7 and then multiplying by negative 1. Just do it at one time. Okay. So the 7s cancel and the negatives cancel. So I'm left with a. And on the right side, we have a negative 11 times negative 7, which is positive 77. And we multiplied by a negative, so therefore that means my sign will change to be a is less than 77. Right. And then we finish that up with a number line. Right. And we should have an open circle, and it should be an arrow to the left to finish that one off. Right. And hopefully that went well. I'm going to write down number 4 and give no clues or hints and see how you do. Negative 6 plus 7x plus 2, and this 7x plus 2 divided by 3 is, is greater than 18. So negative 6 plus a fraction, 7x plus 2 divided by 3 is greater than 18. Good luck. Let's see how we did. So based on the hint that I gave on number 3, anytime you have a fraction, you always have to get rid of whatever is with it first before dealing with the denominator. So I'm going to add 6 to both sides. So I have 7x plus 2 is greater than 3. Sorry, 7x plus 2 divided by 3 is greater than 24. Now I want to deal with the denominator, so I'm going to multiply both sides by 3. I'm left with 7x plus 2 is greater than 72. Then I'm going to subtract 2 from both sides. 7x is greater than 70. Ooh, push that up. Divide by 7 on both sides. And x is greater than 10. Finish that up with a number line. We have an open circle shaded to the right. Okay. Go ahead and double check your work and see how you did on number 4 before we move on to our next problem. Okay, let's move on to our next skill. So another skill we need to consider is if you have variables on both sides. And much like before, we are going to solve like you would for regular equations. However, all caps, if you come across a situation where the variables cancel out, you need to determine if the resulting statement is true or false. Okay. Let's try the next problem, number 5. 4x minus 7 is less than 2 plus 4x. Okay. And just like problems where we have variables on both sides, we want to move that first. So I'm going to subtract 4x from either side. But what results from that is we get a statement that is just numerical. There is no variables. We just have -7 is less than 2. And so we have that situation where we need to figure out, since the variables canceled, is my resulting statement a true or false statement? Is -7 less than 2? Well, all negative numbers are less than positive numbers, so this is a true statement. Okay. But much like last time, we would not just simply put true statement, we would talk about the type of answers we get from a true statement. So therefore, the final answer is all real numbers. Okay. Which means any number replacing the variable will be a true statement. So regardless of what you pick as a variable, or sorry, as a value for your variable, if you were testing it out, you will always get a situation where you have a true statement. So therefore, our final answer is all real numbers. which is similar but not the same as infinite solutions. So again, all real numbers. Now, how do we do a number line for all real numbers? Well, we set it up, and in reality, we always go off the numbers we have here, but we don't have a variable is greater or less than, greater than or equal, less than or equal, another value. So simply, all you have to do is start off with the 0, 1, 2, and -1 and -2. And since all values work, we are simply going to have a line that just goes straight across and is double-sided. And this would be my number line for an all real numbers answer. Okay. Well, let's look at what happens in number 6. 4x plus 7 is less than -2 plus 4x. Go ahead and solve this and take a guess at what you believe the final answer should be. Okay, let's see what happens. So I'm going to subtract 4x from both sides, which results in a numerical statement that 7 is less than -2. Now, there will never be a situation where a positive number is less than a negative number. So this is a false statement. However, the final answer is no solution. Okay, and again, this phrase, no solution or all real numbers, is the exact phrases you should be using. Okay, but no solution, which means there is no number that could ever replace the variable to get a true statement. It will always be false. The final answer is no solution, which means there is no number that could ever replace the variable to get a true statement. It will always be false. So my final answer again is no solution. Okay. And all that means for your number line is that there isn't one. You quite literally will just leave it blank. Okay. You could even do a little X like this, but that would be the end of your answer. So as a reminder and a refresher of what we covered today, we are going to solve our multi-step inequalities, much like our equations, except for our 2 rules, meaning our inequalities signs and symbols stay the same unless you are multiplying or dividing with a negative number. Okay. All other rules stay the same as far as graphing and solving. Okay. When you have fractions, make sure that you are adding or subtracting that step first, unless it is all the way across, like we had on number 1 with a single fraction versus a fraction plus or minus another number. And when you have variables on both sides, you want to simplify those. Now, variables on both sides will not always result in special answers. That's just how we did it on notes. Okay, and again, we do have true and false statements, but we want to make sure we're using our special final answers as done here. Okay. Good luck on your assignment and ask questions when you need.